Space is vast. The distances between stars are immense. Even at the fastest speeds, journeys to other star systems would take many lifetimes. This presents a monumental challenge for space exploration. One intriguing possibility is cryosleep, a state of deep hibernation where life's processes are slowed down. It's a concept familiar from science fiction, but could it become science fact? Cryosleep is about pausing life for a time, not ending it. Imagine a crew of astronauts nestled in specialized pods, their bodies gently cooled, their metabolism slowed to a crawl. They would slumber peacefully, oblivious to the passage of time. Cryosleep isn't just about surviving long journeys. It also offers a way to conserve precious resources. A hibernating crew requires less food, water, and oxygen. This translates to reduced mission costs. Cryosleep continues to capture the imagination of scientists and space enthusiasts alike. Cryosleep relies on metabolic suppression. Our bodies burn energy even at rest. Slowing metabolism reduces resource needs. Therapeutic hypothermia lowers body temperature. Used in hospitals, it reduces brain damage risk. Cooling slows metabolism, aiding recovery. It could enable safe cryosleep, lowering temperature and suppressing metabolism. Astronauts could stay in cryosleep for years, waking up ready to explore. Cryosleep's potential benefits extend far beyond the physiological. Imagine the logistical challenges of sending a crew of astronauts on a multi-year mission to Mars or beyond. The sheer amount of food, water, and oxygen required for such a journey is staggering. Then there's the need for living space, exercise equipment, and entertainment to keep the crew physically and mentally healthy during the long voyage. Now imagine the same mission with a crew in cryosleep. The need for bulky life support systems is drastically reduced. Food and water supplies are minimal. There's no need for spacious living quarters or elaborate exercise facilities. The spacecraft itself can be much smaller and more efficient, requiring less fuel and making the entire mission less expensive. This reduction in mass and complexity has significant implications for the future of space travel. It could make ambitious missions to the outer solar system and beyond more economically feasible. It could also pave the way for smaller, privately funded missions, opening up space exploration to a wider range of participants. The challenges of a frozen slumber. Despite its potential, cryosleep is fraught with challenges. One of the biggest hurdles is the issue of cellular damage. When body temperature is lowered, ice crystals can form within cells, causing irreparable harm. Preventing this cellular damage is crucial for the safe and successful implementation of cryosleep technology. Scientists are exploring a number of solutions to this challenge. One approach involves replacing the body's fluids with cryoprotective agents, chemicals that prevent ice crystal formation. Another avenue of research focuses on developing methods to induce a state of vitrification, where the body's tissues solidify into a glass-like state without forming damaging ice crystals. Even if the technical challenges of cryosleep can be overcome, ethical considerations abound. What are the long-term effects of prolonged cryosleep on the human body and mind? How do we ensure informed consent for a procedure that could potentially have unforeseen consequences decades later? These are complex questions that require careful consideration and open discussion. The ethics of pausing life. The prospect of cryosleep raises profound ethical questions. We are venturing into uncharted territory, tampering with the very rhythm of human life. The implications extend beyond the individual to society as a whole. One of the most pressing concerns is the issue of consent. How do we ensure that individuals are fully informed of the risks and uncertainties associated with cryosleep before they give their consent? What about potential long-term health effects that may not manifest for decades? These are questions that require careful consideration. Then there's the question of psychological impact. How might prolonged periods of suspended animation affect the human mind? Will astronauts wake up from cryosleep with their memories intact, their personalities unchanged? Or could there be unforeseen psychological consequences, such as disorientation, mood disorders, or even a fundamental alteration of one's sense of self? These ethical dilemmas highlight the need for a cautious and measured approach to cryosleep research. We must proceed with a keen awareness of the potential risks, engaging in open and honest dialogue about the ethical implications of this potentially transformative technology. Cryosleep, a bridge to the stars? Cryosleep represents a tantalizing possibility, a potential game-changer in our quest to explore the cosmos. It offers a way to overcome the limitations imposed by time and distance, to reach for the stars without being bound by the constraints of a human lifespan. While significant challenges remain, the potential rewards are too great to ignore. Imagine a future where cryosleep allows us to send humans on multi-generational missions to distant star systems, to explore new worlds and unravel the mysteries of the universe. Imagine a future where cryosleep enables us to establish a permanent human presence beyond our own planet, expanding the reach of our species and ensuring the survival of life in the face of cosmic uncertainty. The road to realizing this vision will be long and arduous. It will require dedication, ingenuity, and a willingness to confront complex ethical dilemmas. But the pursuit of knowledge, the drive to explore, is a fundamental part of what makes us human. Cryosleep, with all its challenges and uncertainties, offers a tantalizing glimpse into a future where the stars themselves may no longer be beyond our reach.